So basically what I just said, we're going to go about the mission objectives. We'll talk a little bit about observation and geometry, but I think that there will be no a secret for you what limb sounding is. The mission element and system, with the platform, the instrument that makes the satellite, the payload data ground segment. We'll talk a little bit about CalVal, even though there is a specific presentation about that this morning, and finally the schedule. So this is a slide that we use in other conferences. I don't think I need to convince you of the need to retrieve ozone and other trace gases. But basically, this is what we're going to be doing. Ozone is our primary trace gas that we're going to be retrieving, and we have some secondary objectives like aerosols, water, NO2, BRO, and so others, temperature, for instance. This boils down to two types of requirements. The first one is the near real-time ozone products with a latency of less than 3 hours. This means that this processing has to be done automatically. We need to downlink data every orbit. And we have a second set of products, the offline products, consolidated ozone and the secondary products. They have a less stringent timelines. They have more human intervention in the processing. And here we, of course, go for the best accuracy. A slide that I think we'll have to change a little bit, seeing some of the missions that have been announced during this conference. But checking at the launch time that was set, they go beyond 2030, and we see that most limb sounders are not making it further than 2025. So ALTIUS will be helping filling the gap between 2025, 2026, and 2030, together with the OMS continuation. So this is a good news for you, I hope, seeing some of the presentation of today as well, that the lack of limb sounding data is not helping. So ALTIUS is a mission, was proposed as an Earthwatch mission. There are not that many. The number of Earthwatch missions are growing. This has some particularities from the programmatic point of view. For instance, only a limited number of countries are contributing to this mission, in this case Belgium, Canada, Luxembourg, and Romania. And if you look for ALTIUS in the set of Earth observation mission of ESA, of course you have the meteorology missions, which are delegated by the EUMETSAT, the ones of Copernicus by European Commission, and finally the science. And then you see ALTIUS there. Next to it, you see FLEX, and it's very nice that they are more or less at the same time as us, because we'll be launched together. Observation comes is a limb sounder, no secret there. Our instrument will be taking monochromatic to the images in 3 channels, UV, VIS, and NIR. This has snapshots, and the wavelength is tunable thanks to Fabry-Perot interferometers and acousto-optical tunable filters. One of the nice things on our mission is that we can do both bright limb and occultation of sun, bright stars, because of SNR, planets, and also the moon. Our field view covers basically up to the upper mesosphere with a horizontal extension of 100 kilometers. We can do additional modes of imaging for calibration. And finally, all this is thanks to a very agile platform that different than other satellites, for example, like InVisat, which was a huge satellite, and the instrument had to move towards the target. Here, we are able to move the whole satellite towards the target. Okay, a small animation that was prepared by our colleagues from BISA. Here, basically, what you have is the different observation modes. First, we had the bright limb, where we fly in the bright side of the orbit. The satellite is pointing backwards, so it's looking at the tangent point that is behind in the orbit. Very similar to OMS, Skiamaki, so this is nothing new there. And this is done for more or less more than half of the orbit. When the satellite is arriving to the terminator, it orients itself to the point where the sun is going to set, and it should be coming soon here. Okay, there it is. So the satellite points to where the sun is going to set, and then we have solar occultation. During the dark side of the orbit, some selected bright stars will be also used as targets for occultation. And finally, as we approach again the terminator, the satellite orients itself towards the point where the sun is going to rise. Then you will see it now. And there we go. And then the cycle repeats. This is what we call the baseline observation scenario. Of course, we can program other things, calibration, tomography, different things. That's one of the nice things of the satellite. So let me see how I go then to the next slide. Okay, so we need to develop this. So we have a development program separated into a space segment and flight operations segment, which is built as by Redwire as prime. The instrument is built by OIB about the NARDE. And then we have the payload data ground segment, which is built by the Space Bell. The development is such that we expect to have everything ready, but the flight acceptance review will launch the satellite. It will be followed by a commissioning with calibration and validation, and then altogether exploitation. The satellite lifetime is 3 years. We'll be generating products, and we hope to have a very nice user community. We're already talking with CNWF because they will be using our near real-time data, our colleagues from Ozone CCI as well, and we expect to reach a very wide community set. The platform, this is the satellite. The platform is P200. There was another mission on Tuesday, the IOD-IOB, that is usually also the same platform with a lot more instruments. It's a rather small satellite, 300 kilograms in volume. Again, we put this because it's for presentation, but here you see, this is a scale 1:1, so you can really see how it is. In terms of powers, we have a 250 watts, which is necessary to basically to do all the observations. The onboard software is quite autonomous. For the bright limb, we just need to say start bright limb and forget about that. The satellite will do all the bright limbs. For the stellar occultation, it's a little bit more difficult because we need to actually say which stars we want. For the instrument, as I mentioned before, we have 3 cameras, independent cameras in the UV, VIS, and NIR. Here you have the spectral range. For the VIS and the NIR, we use an acousto-optical tunable filter, while for the UV, we use a stacked Fabry-Perot interferometers with 4 steps. Our detectors are CMOS. We have a series of electronics. I wish I could open this, but in any case, it's empty because it's just a mock-up. But basically, what you see here is that here is the typical VIS and NIR geometry. So you have the baffle, which is this one here. And then you have, sorry, no, this is wrong. This is the VIS and NIR. So you have light coming in, this periscope basically, and after a series of bouncing in front optics, we have here the filter, and finally it makes it to the detector. For the UV, it's a little bit different. We have 2 entrances. One is for the bright limb and the solar occultation that does basically like this. For the stellar occultation, because of the SNR, we need to amplify the image, so we need a longer focal length. This is the structural thermal model. It's not a flight model yet, but it gives you also an idea that that we're advancing, and I will talk about that a little bit later. I think this we have explained. You will be the Earth, according to what the satellites now exposed, and the sun is over there, and the limb is more or less in this direction. Ground processing, it will be very close. It will be in Uccle, here in Belgium, in the premises of I think probably it could be BISA or BUSOC. Main functionalities is the mission planning, mostly because of the different targets we have to acquire. We need to request payload operations. Then, of course, the data processing, and this would mean the generation of near real-time products, consolidated products, doing in-flight calibrations, recalibrations during the satellite lifetime, checking the data quality, reprocessing when there are versions, because we saw that probably there were versions like all the satellites, and finally storage, dissemination, and catalog. Just a small schematic of the processing chain, you know, with different products. I didn't mention it, we stopped an L2, but we are confident that Dan will use this data for his L3. Finally, a status and a schedule. We are now completing the qualification of many of, if not all, the elements of the satellite for the platform. We are a lot more in advance, and we expect to have the platform finished by Q2 next year. The instrument goes a little bit more slow, but is advancing well. The structural thermal model, this is like basically a quite realistic mock-up of the satellite, of the instrument, for checking that the design in terms of the structural thermal is the right one. And by end of June of this year, actually we're going to put both together, the model of the platform and the model instrument together, to do a series of shock tests, just to be sure that we'll survive the launch. Some optical critical systems also under testing, the qualification models, and we expect that the instrument will be delivered by Q3 2025. Launch, everybody asked me about the launch. Official date is March 26 on board of the Vega C. And as I said before, we're going to be launched with the Flex. And here, of course, we will have a commissioning, orbit calibration, geographic and geophysical validation for primary products until September 2026. Quick comment about Calval. We have separated Calval in two sets. First one is part of the project, as a project endeavor, like I like to call it. And this has the component of the calibration of the instrument in orbit and the validation of the primary products, ozone. There will be a presentation by Christopher Lambert about that. And then we will talk, we're going to launch an announcement of opportunities for validating the secondary products. So I put here the list, so because I try to interest you in participating, in helping us validating these products. Of course, if you have interest also in helping us validate the primary products, or helping us also with in-orbit calibration, these proposals are also welcome. But okay, our focus is on the secondary products. Access to the L2 products and other products and information, of course, needs to be justified in announcement opportunity. That's a typical business. And then some dates for you to consider. The release of the call will be January 2024 with, of course, this is preliminary timeline, it might change a little bit, with closing of the call in May and an announcement of results by July 24. And okay, I said that this is just an introduction. There will be a few more presentations going more into the detail. For instance, L2 processing of the primary products, L2 processing of secondary products, both presentation by BISA. The in-flight calibration of the ALTIUS instrument will be presented by Saskatchewan. There was one paper about the scintillation mitigation also by BISA. Finally, my colleague David from ESA will be presenting a little bit more detail about the system characteristic and performance of the satellite. And finally, geophysical validation plan by Jean-Christophe Lambert. And many more, but I will not go into detail. There are a few more talks and posters as well that invite you to have a look.